Welcome to all for the course Machine Learning CS467 Module 4 Part 2 video. Myself, Meherba Namas, Assistant Professor, Department of Computer Science and Engineering, Rajagiri School of Engineering and Technology. In the previous video, we have discussed the ID3 algorithm for constructing decision tree. ID3 stands for Iterative Dichotomizer Tree. So in this video, I'm going to explain the next algorithm which is called CART algorithm. So CART stands for Classification and Regression Tree. So CART is a binary decision tree that is constructed by splitting a node into two child nodes repeatedly, beginning with a root node that contains the whole learning sample. So let's see what are the different main elements of CART. So the first element is the rules for splitting the data at a node based on the value of one variable. Another element is stopping rules for deciding when a branch is terminal and can be split no more. And third one is a prediction for the target variable in each terminal node. So these are the three main elements of classification and regression tree. So CART is mainly a form of binary recursive partitioning. I have already mentioned. So let's see why it is called binary recursive partitioning. So in this algorithm, the data is split into two partitions and the partition can also be split into sub-partitions. So this procedure is a recursive procedure. And CART tree is generated by repeated partitioning of the dataset, and parents get two children and each child produces two grandchildren and four grandchildren produces eight grandchildren. So it's like a binary recursive partitioning. So let's see what is recursive partitioning. So first of all, we need to take all of your data and consider the all possible values of all variables and select the variable or a value that produce the greatest separation in the target. That is x which is equal to t1, that is called a split value. And if x is less than t1, then send the data to the left. Otherwise, send the data point to the right. And we need to repeat the same process on these two nodes and finally you get a tree. So CART only uses the binary splits. So let's see what are the key parts of tree structure data analysis. So the first part is tree growing, second part is tree pruning. So let's see what is tree growing. So splitting rules to generate a tree and how we can stop the tree construction. So it is the stopping criteria is how far to grow. And the missing values using substitute we can replace instead of a missing values. And tree pruning means trimming of parts of the tree that don't work and ordering of the nodes of a large tree by contribution to tree accuracy and which nodes comes off first. Then finally the optimal tree selection, deciding on the best tree after growing and pruning. And also here we need to balancing the simplicity against the accuracy. So let's see what are the different CART algorithm steps. So first step is take labeled input data with a target variable and a list of independent variables. And second step is the best split. Find the best split for each of the independent variables. And third one, it is best variable. Select the best variable for the split. And fourth step is split the input data into the left and the right nodes. Continue steps 2 to 4 on each of the nodes until meet a stopping criteria. Finally, we have to do pruning, that is decision tree pruning, steps to prune decision tree build. See, a tree is grown starting from the root node by repeatedly using the following steps. So in this slide, I will discuss more details about each step. So first one, find each predator's best split. So how we can find the predator's best split? So for each continuous and ordinal predator, we have to sort the values from lowest to the highest value. And for the sorted predator, we have to go through each value from top to examine each candidate split point and to determine the best point. So in this step, we have to determine which is the best split point. So the best split point is the one that maximizes the splitting criterion the most when the node is split according to it. So for each nominal predator, examine each possible subset of categories to find the best split. So for a continuous it is different, and for the nominal predator it will be different. The next step is find the node's best split. Among the best splits found in step 1, choose the one that maximizes the splitting criterion. And the third step, split the node using its best split found in step 2 if the stopping rules are not satisfied. So let's see what is a splitting criteria for a categorical dependent variable. Suppose if y is categorical, there are 3 splitting criteria available, that is Gini and rowing and ordered rowing criteria. What is Gini criterion? So Gini impurity we have already explained in the previous video. So Gini impurity is measured at a node T is defined as the continuous dependent variable when y is continuous and the splitting criteria is used with the least square deviation, that is impurity measure. The advanced cart also has other splitting criteria which is called towing as recommended for the multi-class. So let's see how we can stop the tree building. The tree building process goes on until it is impossible to continue, and the process is stopped when first one, all the observations within each child node have the identical distribution of predicted variable, and second one, an external limit on the number of levels in the maximal tree has been set by the user. And third one, an external limit on the size of the terminal nodes in the maximal tree has been reached. So these are the 3 stopping criteria for tree. So in this slide, I am going to explain what is pruning. So cart lets tree grow to full extent, then we need to prune it back. So idea is to find that point at which the validation error is begin to rise. So we have to generate a smaller tree and by pruning the leaves. At each pruning stage, the multiple trees are possible, and here we need to use cost complexity and to choose the best tree at that stage. Let's see what are the different features of a cart. So definitely any decision tree contain nodes. So for the cart, first of all the feature is nodes, the root node, parent node, child node, terminal node. The second one is a binary splits. A node in a decision tree can only be split into 2 groups, and each split is based on only one variable. And fourth one is the recursive partitioning. So binary partitioning process can be applied over and over again, and each parent node can give rise to 2 child nodes, and in turn each of these child node may themselves be split forming additional children. So next is what is tree pruning. So in order to generate a sequence of simpler and simpler trees, each which is a candidate for the appropriately fit final tree, and the method of reduced error pruning can be used, and each time we remove the weakest link that provide the least improvement in misclassification, and this misclassification error is increased during the pruning process. So the most commonly used pruning is cost complexity pruning. So next is optimal tree selection. How we can select the optimal tree. The maximal tree will always fit the learning dataset with a higher accuracy than any other tree. because the maximal tree is constructed to optimize the performance based on the learning data set. So how we can select the optimal tree with respect to the performance to find the correct complexity parameter so that the information in the learning data set is fit but not overfit. So in general, in order to finding this value would require an independent set of data, but this requirement can be avoided by using the technique called cross validation we have already discussed in the module 3. So let's see what are the different advantages of CART algorithm. There is no parametric assumptions, can cope with any data type. It can be continuous, binary, ordinal and nominal. And classification has a simple form that it is easy to understand. CART identifies splitting variables based on an exhaustive search of all possibilities. And it handles the complex interactions well and is robust with respect to outliers and provides an estimate of the misclassification rate. Let's see what are the different disadvantages of CART. So first disadvantage is CART does not use combination of variable in each split. Tree structure may be unstable. Tree is optimal at each split. So next I'm going to explain the general issues in decision tree learning. It can be any method if you are using CART or C4.5 or ID3. What are the common issues in decision tree learning? One of the main problem is the overfitting. So trees are grown deeply enough to perfectly classifying the training example. So definitely this lead to overfitting the data. So when there is a noise in the data or when the number of training examples are too small. So the definition is the hypothesis overfit the training example if some other hypothesis that fit the training example performs better over the entire distribution instances, including the instances beyond the training set. So this is the standard definition of overfitting. So in this graph, you can see what is the impact of overfitting in a typical decision tree learning. The accuracy of the tree over training examples increases monotonically, whereas the accuracy measured over independent test samples first increases, then you can see the value is decreasing. Let's see what are the different approaches to avoid overfitting. So first one called pre-pruning and second one called post-pruning. Pre-pruning is halt tree construction early and post-pruning means remove branches from a fully grown tree. So let's see what is pre-pruning. We may apply pruning earlier, so before it reaches the point where it is perfectly classified the training data. And do not split a node if this would result in the goodness measure falling below a threshold value. The problem is so difficult to choose an appropriate threshold value. Let's see what is post pruning. So post pruning is remove branches from a fully grown tree. So we may allow the tree to overfit the data and then post prune the tree. So one commonly used criterion used to determine the correct final tree sizes get a sequence of progressively pruned trees and use a set of data different from the training data and we can decide which one is the best pruned tree. So let's see how we can reduce the error pruning. We consider each of the node to be a candidate for pruning. So pruning a decision node consists of removing the subtree rooted at that node and making it a leaf node and assigning it the most common classification of the training example affiliated to that corresponding node. The node are removed only if the resulting pruned tree better than the original over validation set. And nodes are pruned iteratively and pruning of node is continued until further pruning decreases the accuracy of the over the validation set. So let's see what you mean by problem of missing attribute. So in this data set you can see some of the features. So these are different symptoms and the final one it is a disease prediction. So some of the symptoms are missed we don't know whether it is yes or no. So how we can deal this issue? Most of the machine learning algorithm will face this issue. So let's see how we can deal this problem. So the problem of missing attribute can be handled by using following method. So first one, deleting the cases with missing attribute value, replacing a missing attribute value by the most common value of that attribute. Third one, assigning all possible values to the missing attribute value, replacing a missing attribute value by the mean for numerical attribute. Finally, assigning to a missing attribute value the corresponding value taken from the closest t case, or replacing a missing attribute value by a new value. So these are the methods we can replace or we can remove the missing attribute values. In this video, we have discussed what is meant by CART and how we can construct decision tree by using CART algorithm, and what are the different steps in order to make a decision tree by using CART algorithm, and what is tree pruning and how we can deal that issue, and how we can overcome the overfitting while we constructing the decision tree, and how we can deal the missing attribute value. So thank you all for watching this video.